All right, now what we could do, we could put our numbers in, but I'm going to just go through the steps of algebraically isolating R, because that's what we're looking for. It's going to look like this. All right, and you'll have to take a cube root at the end. I'll help you with that if you haven't done that on your calculator before. So now let's go ahead, pop our numbers in. There's Newton's gravitational constant, mass of the Earth, period, which we've written up at the top there, it gets squared, all over 4 pi squared. Okay, and just a reminder that what you get there is going to be r cubed. Okay, so I'm going to go through, get a number for you. Okay, one thing I just want to point out, because I want everybody to get it right, I've inputted the numerator. Okay, I always like to put enter and then divide at the end, but if you don't put 4 pi squared in brackets, what's going to happen is it's going to divide by 4 and then multiply by pi squared, and you definitely don't want that. Okay, so when I do this, I get 7.53 times 10 to the 22. That's r cubed, so you need to take a cube root. There's different ways of doing it. Here's what I do. I do to the power of 1/3. That's a cube root. You're welcome. There's another way of doing it. You go into math, I think, but that's what I do. So there's my answer, 4.22 times 10 to the 7. Okay, but that is its distance from the center of Earth. Because remember, all of these r's, orbital radii, are from the centers. It never mattered when we were talking about planets because the distance away from the sun is so great that the radius of the sun doesn't matter, doesn't add anything to it. It changes like the 8th decimal point or something like that. But satellites are closer to the Earth. Okay, so when you get r, that includes the radius of the Earth. And I specifically asked for altitude in this question, so we're going to have to subtract the radius of the Earth. So what I'm writing here, altitude is going to equal 4.22 times 10 to the 7. Subtract the radius of the Earth, which is on your formula sheet, 6.37 times 10 to the 6. So its altitude is 3.59 times 10 to the 7 meters. Okay, just for scale, that's what 35,900 kilometers. Oops, you can see that, we cannot. All right, so how does that compare to the International Space Station? Okay, it's about 100 times farther. Okay, or if you like, it's about 5.6 times the radius of the Earth away. So I am just eyeballing this. 1, 2, 3, 4, 5. All these geostationary satellites will be way out here. There's hundreds of them. Okay, way farther away than the International Space Station. The ISS, really close to Earth. That's why it has such great photos. All these communication satellites are way out here. There are more in between, of course, but geostationary is super, super crowded as far as space goes. All right. How does that compare to the moon? Great question. Well, how far away is the moon? I think I got it written down over here somewhere. Looked it up. Nope, I didn't. Let me get back to you on that.